We proved some statements and disproved some for integers. Now let us move on to rational numbers. First of all, what's the definition of a rational number? Definition of a rational number. A real number like R is rational if and only if R can be written as the quotient between two integers a and b such that b is not 0. A and b are both integers and b, the denominator, is never 0. Okay, example. Is 0 a rational number? Yes, it is. Why? Because 0 can be written as 0 divided by any number. 0 can be written as, for example, 0 divided by 1. Or you might say that 0 can be written as 0 divided by 10, any number that you like. 0 divided by a number. The denominator is not 0, the numerator is just an integer. So the answer is yes. What about if I flip these? B is 2 divided by 0 a rational number? We're going back to algebra. Of course not, because the denominator is equal to 0. C is 0.12, 12, 12, 12. The number repeats itself. A rational number? Let's try to break this down. What do we have here? We have this decimal number which repeats itself. Let x be this repeating number. So I'm going to try to get rid of these decimals by multiplying both sides by 100. Multiply both sides by 100. So you get 100x equals to, well, here you have 12.12, 12, and the rest repeats itself. I have 100x, I have x. What I'm going to do, I'm going to subtract these two. I get 100x minus x, which is defined as 12.1212, the rest, minus 0.1212, and the rest repeats itself. So as you can see, you can get rid of the decimal part. Here you have 99x equals to 12, right? So 99x is equal to 12, so x is equal to 12 divided by 99. As you can see, it satisfies the definition of a rational number. This is a over b, and b as 99 is not 0. So the answer is yes. We have a rational number. For some cases like this, you can usually use the definition and check to see if you have a rational number or not. But for more general statements, like universal statements, you need to use the direct definition of the rational number to prove it for general cases.